All right, good morning, boys and girls, and welcome back. Today we're talking about the length of curves. If I want to find, if I've got some curve like that, and I want to find the length of that curve from some point A to some point B, I want to find the length of that curve right there, then what we're going to do is we're going to use one of these two formulas. I can go from A to B. I guess in this case that's what I'd use. 1 plus f prime of x squared dx. Okay, the square root of all that stuff. This is how I'd find it if I was integrating in terms of x, which is kind of how I have this drawn. However, I could also maybe do this in terms of y. If I use the y coordinates at these points instead, I should have maybe changed my variables. Let's call it from c to d, where c is that point there and d goes to that point right there. Then you could also do the integral from c to d, c to d of the square root of 1 plus g prime of y squared dy. Okay. More formulas we got to memorize. The main thing to memorize, that if you do it in terms of x or in terms of y, it's your interval, whatever you're doing, from a to b or c to d, root of 1 plus the derivative of the function squared. Okay, that's what we need to know. All right, so let's do a few of these then. All right, so first example here, we want to find the length of the curve of y equals 2x to the 3 halves plus 3 on 0 to 9. First thing you might want to do is sketch it or get an idea of what this looks like if you can. In this case, I don't know what it looks like off the top of my head, so I'm going to pull up my handy-dandy calculator here. And I entered it into it here for us already. Y equals 2x to the 3 halves plus 3. I changed my window to go from 0 to 9. And now when we graph it, we get this graph here. So it kind of looks like a kind of parabola-y, opening up. So, kind of looks like that. That's what we're going to try to find the length of curve of, or the arc length of. Okay, so again, to find the length of our curve, or this arc length, what you're going to do is you are going to use our little formula right here. All right, so in this case, our length of our curve is, we're going to go from 0 to 9, our limits, root 1 plus, I need to go find f prime of x, so I got to find the derivative. So I'm going to come to the side here, y prime is 3 halves times 2 is 3x to the 1 half. The derivative of 3 is 0, so 3x to the 1 half, or y prime is equal to 3 root x. All right, so I now need to plug that in, and we are going to square it dx. And so once you know the formula, this is really just little plugging and chugging. S equals the integral from 0 to 9 of the square root of 1 plus root 3, or 3 root x squared is 9x dx. And I guess now if I wanted to integrate this by hand, I would be doing a little u sub, right? U equals 1 plus 9x. So du is 9 dx. That's working out nicely. So du over 9 equals dx. So s equals the integral. I've got to change the limits because I'm going to terms of u. So if I plug in 0, I get 1. If I plug in 9, I get 81 plus 1, or 82, root u du, and I forgot my 1/9. I can pull that 1/9 out in the very front. I got excited about remembering about my limits. So this is s equals, so now that's easy to integrate. 1/9, the antiderivative of the square root of u, or u to the 1 half, is u to the 3 halves over 3 halves. From 1 to 82, or sliding up some more. That means my arc length is going to be 1/9 times 2/3. So 2 over 27. U to the 3 halves, evaluate from 1 to 82. And then you would plug these in. In this case here, I did all that work just to remind us of little u sub. But when you plug that into your calculator, you're going to get something like 54.929. I mean, it's not going to be a pretty number when you plug that stuff in, but you should get like 54.929 is the length of our curve. But that's how we use the formula. Okay, next one here again, we want to find the length of the curve on this parabola from -2 to 1. like if you can sketch a picture, you don't always have to. I'm going to do it one more time just so you kind of get a picture of what we're trying to do here. But if I was going to try to graph this, I might put it into vertex form, or sorry, intercept form. I can see this is going to factor to x plus 2, x minus 1. So I know that this is crossing at -2 and +1. I could do, to find the vertex out of here, it's x equals p plus q over 2, if you remember. Or -2 plus 1 over 2, which gives me -1/2. So I know my vertex is going to be at -1/2, and again, this is good enough for here somewhere. What is going on again? Why does that do that? I have no idea why OneNote just shuts down like that. But I know it's got to be below the x-axis because this is opening up. And so again, we're just trying to rough sketch it here, but it would look something kind of like that. So we're trying to find the length of this curve right here. Okay. As far as doing this, I don't really need to do all that to find the length of the curve, but sometimes it kind of helps a little bit just to visualize. So to find the length of the curve, though, again, it is s equals integral. So we're going from -2 to 1, square root of 1 plus the derivative squared. So again, I need to go find y prime. Y prime is 2x plus 1. So this is going to be 2x plus 1 squared dx. And so that's how I'm going to set this up. In this case, well, might as well go and do it. If I go to simplify a little bit here, s equals -2, root, like we did last time, 1 plus, this is 4x squared plus 4x plus 1 dx. Or we get, forgot my integral. Or I get s equals integral from -2 to 1 of the square root of 4x squared plus 4x plus 2. You might get, and these are frequently calculator problems, but this is something that we can't integrate. So I'm just going to plug it in on my calculator, math 9, and go to town. But in this case, you're going to get something like s is 0.6. Verify me if you want to. But frequently, these will be non-calculator questions, although I'm going to show you one here, which is a tricky non-calc one that we should see. All right? One other thing here. Sometimes they might ask you, instead of just to find the arc length, they might ask you to find the perimeter, okay? Find perimeter of the object, of the shape. So in this case, you would have to find the arc length. And then, if I wanted the perimeter of this enclosed area, then I'd have to add 3 to it. So my perimeter would be 5.653 plus 3. And again, I'm getting 3 because I'm going from -2 to 1. So that is a distance of 3. And so the perimeter of this shape that I just drew there would be 8.653. All right? So don't forget that. All right, one more example. Okay, I want to find the length of this curve from 4 to 16. All right, so again, in this case, I'm not going to draw a picture because we don't always have to. I'm just going to go straight to the formula. So this is s equals integral 4 to 16 of square root of 1 plus f prime of x squared. So f prime or y prime, I got to go find my derivative. Y prime is 3/2 times 1/3 gives me 1/2 x to the 1/2 minus 1/2 x to the -1/2. Running out of room there a little bit. All right, so that's my derivative. 1/2 x to the 1/2 minus 1/2 x to the -1/2 squared dx. All right. And then now I need to go ahead and, like before, if I'm not able to use my calculator and just plug in, like on those ones I would probably just plug in. If I could use my calculator, I'd plug in right here. But if I can't, I'm going to go ahead and now I have to multiply this out. So if I multiply it out, we're going to get something that looks like this. All right, when I double distribute 1/2 x to the 1/2 minus 1/2 x to the -1/2, and I square that, I'm going to get 1/4 x minus 1/4 minus 1/4 plus 1/4 x to the -1st. All right? Or when I simplify this, I'm going to get 1/4 x plus 1/2 plus 1/4 x to the -1st. -1/4 is -1/2 plus 1, 1 minus 1/2 gives me that positive 1/2 right there. All right. And now then I need to integrate this. Or I'm gonna, again, I don't have a calculator, so I got to try to integrate it by hand. And U sub here doesn't quite work. But like, I don't think you'd normally see this. I don't know if I ever saw it my first time. It's only now that I know to look for it that I see it. But this is another perfect square trinomial here. Okay, this is very similar to the one we had right here. I could rewrite this as 1/4 x plus 1/4 plus 1/4 plus 1/4 x to the negative first. So this is like the same one, except for this one is going to factor to s equals the integral from 4 to 16 root 1/2 x to the 1/2 plus 1/2 x to the negative 1/2 squared. Okay, that will factor that right there. And again, just watch out, look for this trick. I think there's at least one problem on the homework tonight where that will come up. Okay, so just kind of be careful and pay attention for it. But now that I got a quantity squared being square rooted, you can square root just kills it off. So that I get to something here that I could integrate. And like maybe now you pull out that 1/2, and I will let you, from here, I'll let you try to integrate on your own. I think I'm going to stop. Where are we at time-wise? Yeah, I'll stop. I'll keep this video short. We should be able to integrate that right there. And I'm just going to say that when you do this, that factoring trick was the part I wanted to show you. When you do this, you should get s equals 62/3, though. Okay? Maybe try to work that out and see if you get there. All right, boys and girls, that is length of curves or arc length. See me if you got issues, and see you later. Have a great day.